Welcome back, y'all, to some more algebra. So we are going to start into graphing. So we're going to break this up into two parts. This first part, we're going to just talk about graphing and equations, and then we'll get into other things next week. But we're going to start out with just one lesson this week. So let's get into it. So let's look at the parts right here. Now, this whole graph, the graph with the lines right here, this whole thing is called Cartesian graph. It's created by a man named Rene Descartes a long time ago. He kind of used it as a way to really track and navigate things from a certain point. That certain point, also known as the origin, where we start this whole thing, is called the origin. Has a value, if you don't remember, the coordinates for that is 0, 0. When you're at the home, it's just 0, 0. Now, everything moves in an XY form. Now, you can move diagonally, but you can move in an X form, which is a left to right, or a Y form, which is up and down. That's those values right here. These call an order pair. An order pair has a X coordinate and the Y coordinate. It tells you kind of how far to move from the origin. So for example here, if we were graphing this point right here, this point that's right there, you'll graph 5, 4. Now, to do that, you always grab the first one. The first point represents how far you move left or right. Because this is a positive, we move in a positive X direction. If this is a negative 5, we move in a negative X direction. And as we get to the 4, if it's a positive 4, we move up in a positive 4. If it's a negative 4, you move down in a negative direction. So, for example, 5, 4, we go 1, 2, 3, 4, 5 on the X, and then you do your Y value. 1, 2, 3, 4, and then you graph your point. So this is 5, 4. So if we were given this point right here, well, let's figure it out. How far from the origin do we go, left or right? In this case, we're going left. We're going 1, 2, 3 units, -3. So this has a value of -3 on the X coordinate, and then the Y coordinate will be 1, 2, 3, 4, 5, 6, 7, 8, comma 8. -3, comma 8. That is our coordinate order pair. That's the proper term for order pair. So we're going to try to use as much math terms here. So when I say them and you say them and we say them, we'll recognize these. So again, this is X coordinate, Y coordinate. This whole thing is called an order pair. Your Y axis, your X axis, and of course your origin. Of course, this whole thing is being drawn on a Cartesian graph. We probably won't use that one as much. All right, so when solving for an equation, we're looking for an order pair of x, y. Now, they're going to give you an order pair and say, hey, does this order pair work with this equation? Well, let's figure it out. So, for example, equation 2x plus 3y equals 18 has a solution x, y. It has an order pair that fits in there perfectly. Now, there's other sets of x, y's that will work, but we want to know, hey, does this work right here? Well, the best way to do is substitute. Now, remember, this first letter, the first number is the x coordinate, the second one is the y. Those will also substitute here. So let's see if this works. We're going to substitute those in there. So we have 2 times -5 plus 3 times 7. That equals 18. Doesn't? I'm going to put a question mark here. But we're not sure. Let's double check. So 2 times -5 gives us -10. 3 times 7 is 21. -10 plus 21. What does that give us, class? That gives us an 11. Does 11 equal 18? No. So this order pair does not work. Let's check this one. So 3 for x, 4 for y. So we'll have 2 times 3 plus 3 times 4. All we're doing is just substitute the value of x and y in for x and y. The set of order pair right here. See if this works. So 2 times, and put a question mark because we're not sure yet. 2 times 3 gives us 6. Okay. 3 times 4 is 12. Does 6 plus 12 equal 18? Yes. So this is a order pair for this. That is a solution to this problem. All right. So let's look at a couple more things here. All right, so we're going to graph an equation using just the x and y intercept only. So let's talk about that first. Now, the x-intercept is a point on the x-axis where the value of y is 0. The y-intercept is a point on the y-axis where the value of x is 0. So to find the value of a in this case, make the value of y 0. To find your x-intercept, to find your y-intercept, you make the value of x 0. So let's go ahead and find the x, y intercepts for both of these, and we're going to graph them both. So start with the x-intercept. So we'll make x red. So x is red, and y will be blue, just to kind of keep those in order. So first things first, to find the x-intercept, we got to make the value of y 0. So we're going to say, hey, 2 times 2x plus 3 times 0 equal 18. Okay. So let's do that. So we get 2x plus 0 equals 18. The value, 0 is 0, so just 2x equals 18. We divide by 2. What do we get, y'all? X equals 9. Okay. So that means the x-intercept is 9, 0 because the value of y was 0. So let's look at the y-intercept. Same problem right here. Let's get y-intercept. So this time we're going to make the x 0. We'll say 2 times 0 plus 3y equals 18. Okay, so that gives us 0 plus 3y equals 18. So 3y equals 18. We divide by 3. What does y equal? 6. So that means the order pair for this is 0, 6. So now when we graph this, we're going to make this equation, this green right here. So graph this, we graph these points first. So we'll say, all right, 0. So 9, 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9, 0. And then 0 on the x-axis, and then 6 on the y. 1, 2, 3, 4, 5, 6. Good. Now the graph for these points, this line right here, I'm gonna pick a line, get some arrows, and we say we're gonna make it green. We can go from the y-intercept to the x-intercept, and bam, that is the graph for this equation. Now this is a linear equation. The reason it's a linear equation is because it has an x and a y. It's x to the power 1, y to the power 1. If it was a fraction or had up 2 second squares or cubes, it's no longer a linear. We talked about this before, but let's just a refresher. So I'm gonna let you guys try this. So you guys find the order pair of that and then graph it, and then we'll come by. So go ahead and pause and try that. All right, so hopefully you pause and try that. So you should have got, let's see what you get. So we're finding the y-axis, we could do 5 times x minus 3 times 0 equals negative 15. So we end up getting 5x equals negative 15 divided by 5. X equals negative 3. So the order pair for that is negative 3, 0. So that's our x-intercept. And our y-intercept, we're doing this purple. We'll do 5 times 0 minus 3y equals negative 15. So we get a negative 3y equals negative 15. Divided by negative 3. We're going to be getting y equals positive 5. It's positive 5 because negative divided by negative is positive. So the order pair for that is 0, 5. So if I was graphing these, I'll be at 0, 5, 0, 1, 2, 3, 4, 5 right there. And then our x will be at negative 3, 1, 2, 3, 0 right there. So then the line for this, we're going to make it in this nice little hot pink right here. The line for this will go from one end to the other. Hot pink. So we go from here to there, y'all. And that is our line. So we graphed our equation using only the x-intercept, y-intercept. Now this is an easy way of doing this, but it kind of is a little tedious because you go through the x's and then the y's. You got to find them both, graph them, and then draw a line. Let's look at a different way of doing this. What about solving a line using slope-intercept? Now, this is called slope-intercept because once we arrange our equation, we're going to have the slope and the y-intercept to guide us in graphing this. So slope-intercept form, if you don't remember, is in the form of y equals mx plus b, where the slope is the m and the y-intercept is b, right here, the value of b. Whatever is in those two spots, that is our slope and our intercept right here, our y-intercept. Now, so the best way to do it, again, is to get y on its own. So let's kind of work this problem out. We're going to do this with it in this blue right here. So y is already here, so we're going to go ahead and subtract 3x from both sides. Now, you cannot subtract the 3x from the negative 10, so you just write it beside it. So we'll say negative 5y equals, and like it says right here, it's the x first, so we could do negative 3x and then plus b, so minus 10, because it's a negative 10, so minus 10. And then we're going to divide. So again, we have to get y absolutely by itself. So we're going to divide both sides by negative 5, negative 5, negative 5. So right here we get a positive y answer. Here gets a negative 3 over negative 5, and it becomes a positive 3 over 5. And it's okay to leave it at a fraction. Perfectly okay. And then negative 10 divided by negative 5 gives us what, class? Yes, a positive 2. All right, so now we have all the parts we need. We have our m, or slope, and our y-intercept. So this tells us where to start on, we set the y-intercept spot. So the y-intercept is always on the y-axis. It's at the positive 2, 1, 2, right there. From that spot, we're going to do our slope. Now, our slope, 3 over 5, is what we call rise or run. So it tells us how many times to go up or down. Down if it's negative, up if it's positive, and left and right. Again, left is a negative, right if it's positive. You have to do both, and then you make a point. So from our y-intercept, we're going to do a positive 3, 1, 2, 3, and a positive 5, 1, 2, 3, 4, 5. And then we make a point. And we can keep going. We don't have to just make, we keep going. 1, 2, 3, 1, 2, 3, 4, 5. Now, if you feel that it's not enough, you can also go backwards. You can go negative 3, negative 5. The reason we can do a negative 3 and negative 5 is because that has the same value as 3 over 5. It's just going the other way. So the value didn't change, just the look of it. So from our y-intercept, we do negative 3. So we go down this time. 1, 2, 3, and then negative 5. 1, 2, 3, 4, 5. Let's check that out. It just falls in line right here. Let's double check. Let's connect the dots. Bam, bam. Look at that. All those other points fall nice in line. I'm going to do some lime green so it'll be a little bit easier to see our points. Lime green. There's a one that we originally used, and then there's another one right there. You can kind of use it. You can see our y-intercept right there, and right there. So lines up nicely. And we're going to stop there for today. This is just part 1 of this, but this all kind of chunks together. So we're going to just stop right there. But y'all have a great day. Bye.